In this video, I'm going to talk about multiple linear regression models, and in particular, I'm going to talk about the interpretation of these data parameters. I'm going to start with a simple case of two explanatory variables only. That is, our dependent variable y will be a function of two variables x1 and x2 only. We want to know what is the impact of x1 on y. We may also be interested in knowing what is the impact of x2 on y. Beta 1 will show the impact of x1 on y, and similarly beta 2 will show the impact of x2 on y. The question that we want to answer is how y changes when, say, x1 changes or x2 changes. So as usual, beta 0, it will represent the intercept. That is the value of y when x1 and x2 are equal to 0. The interpretation of beta 1 and beta 2 are a little bit trickier here. So beta 1, it shows the change in y with respect to x1 holding x2 constant, right? Looking at this formula, we can write it down as this is the change in y caused by change in x1, that is equal to beta 1, but we have to assume that x2 is not changing, it is constant. That is what this holding x2 means. Similarly, what is the impact of a change in x2 on y? It is beta 2 holding x1 constant. That is, we assume that x1 is not changing. We can extend this model to include more than two variables on the right hand side, and we can write this type of model as a model with the k variables. This model has k variables on the right hand side. It is the same model that we saw earlier, except that we have more than two variables on the right hand side. Beta 0 again represents the intercept, and it again represents the value of y when all these variables x1, x2 up to xk are equal to 0. Beta 1 shows the impact on y when x1 changes by 1 unit holding all other variables, that is from x2, x3 up to xk constant. Similarly, beta 2 shows you the impact on y when x2 changes by 1 unit holding x1, x3, x4 up to xk constant. So we assume that all other variables are held constant, and beta k shows the change in y when xk, that is the kth variable, changes by 1 unit holding all other variables constant. Okay, so this was the multiple linear regression model where we try to predict a variable y depending on multiple x variables or multiple explanatory variables. And essentially we know that by including more than one variables we can improve the predictions of our y variable. We'll keep talking about these beta coefficients, and I'll show you an example in R about how to interpret these beta coefficients and how to evaluate the goodness of fit. That is, how to judge how well these x variables are explaining or predicting our y variable. Alright, I'll see you in the next video. Bye bye.